Okay, in this question here, we're considering a different rational function. It's factored already for us. So let's go ahead and graph it. And let's take a look at it, zoom out a little bit. All right, so let's look at the domain. The domain is going to be all real numbers except your restrictions, which in this case would be +2 and -4. And we'll put the -4 first. But let's just verify that at +2, the graph says undefined. Remember, that's a hole in the graph. And at -4, the graph doesn't ever want to touch it. So -4 is your vertical asymptote. You see how that vertical line, here, watch this. X equals -4. That line never wants to get touched by the graph. So that's your vertical asymptote. So the points of discontinuity, the hole in the graph would be x equals 2, and that's the removable point because you can cancel that out. You could factor the x minus 2's out, right? Those are gone. So the -4 would be your vertical asymptote. Now, does the graph appear to approach a horizontal line? Well, it looks like if you zoom out, it does want to get flattened both directions, but it doesn't seem to be 0. Seems to approach a higher number than 0. No matter how far I go out, that graph wants to get closer and closer to 1, both on the left end and on the right end. All right, see how that's getting closer to 1 there? Real close. So it's not going to be 0. So let's take a look at what would happen if I multiply these factors out. If I do a little FOIL, then I have, x squared, -2x, -5x, -7x, and then -5 times -2 is +10. So x squared minus 7x plus 10. And then the denominator, you can do the same thing, x squared, 4x, -2x, -8, and those combine to x squared plus 2x minus 8. Now, if you notice, these are both the same degree, which is 2. And if they're the same degree, then we can actually look at the coefficients for those degrees. And those are both going to be, in this case, 1. So since A and B are both going to be 1, it turns out that you can find the horizontal asymptote. If they have the same degree, you can just take that numerator coefficient and divide it by that denominator coefficient. So in this case, it'd be 1 divided by 1, which should be 1. So I'll put that 1 there. And we're going to verify in Desmos that all 3 of these lines are interacting with this graph. So if you graph y equals x minus 5, x minus 2, x minus 2, x plus 4, your original graph, and then you graph the vertical asymptote, x equals -4, x equals is vertical. If you graph the horizontal, y equals 1. You can see how that graph is centered around those lines, okay? But it's never going to touch those vertical and horizontal lines. It'll approach it. Now, something you can think about and I can prove to you with the horizontal asymptote, if I made this coefficient up here 2, notice that brings that up, right? 2 divided by 1 is 2, so that would change that to y equals 2. And if I made that 5, that would change that to y equals 5. Or if I made this 6, but I made this 2. Well, 6 divided by 2 is 3. So it's always going to be the coefficient of the top divided by the bottom if the degree is going to be the same for that horizontal asymptote. But notice the vertical asymptote didn't change, right? It's still going to be x equals -4, no matter what I do with those coefficients.